Hi, I'm Ian Hanomansing. We're live from the Kennedy Space Center in Florida. The countdown is on for the historic Artemis II mission, set to be the first shot around the moon in over half a century. NASA says the rocket and its crew are both ready to go. All they need are the right conditions for liftoff. And here are the launch windows available in the next few days. The first 2-hour window begins tomorrow at 6:24 p.m. Eastern. Now, if the launch doesn't go ahead, they can try again on Thursday evening at 7:22. After that, the next chance will come Friday, 8 p.m. Eastern. One of the biggest issues here is the weather. So far, NASA says it's optimistic about tomorrow's forecast.
Of course, weather has been a nuanced thing for us at times here in the generation phase of this mission. But again, look outside right now, great weather. Hopefully we will keep all of that, although the breezes continue to be an issue for us, but a minor one for us in terms of weather.
CBC climate and science specialist Darius Mahdavi has been keeping a close eye on the weather for us from Vancouver. And how is it looking, Darius, for tomorrow's launch?
Things looking pretty good, Ian, about as good as they could at this point. I mean, as always, there's a little bit of uncertainty in there, but just under 24 hours from that launch window opening, things are looking optimistic. Right now, NASA puts it at an 80% chance that we will see favorable enough weather conditions to launch tomorrow, which is good news. That forecast comes from the U.S. Space Force as well. They have a special division that is just meant to forecast for missions like this. A few of the things that they mentioned we'll be watching for is the cloud cover that we have. Very slight chance of any precipitation, not really any risk of storms or anything like that. Very little risk of that, at least. But we will still be watching for that cloud cover. And of course, it's not just the weather here on Earth that we're worried about. I mean, sure, if we have very strong winds, which seems unlikely at this point, that could disrupt the mission. But there's also space weather to be concerned about. And NASA spoke about that in their press conference earlier today. Beyond the cloud, what we're looking at is all the way out on the sun. This solar flare happened, we've been watching it since yesterday. It's a very strong flare, but most of that energy is not pointing towards the Earth, which is a big deal here. Solar flares can disrupt electronics and would make for a pretty unpleasant ride for the astronauts on board the rocket. And so, fortunately, again, strong solar flare, but not pointing towards Earth. If that remains the case, if we don't see any changes on that front, then we should be looking pretty good to go tomorrow. Ian?
It is just a little window into how complex this rocket launch is when you are literally looking at weather conditions on the sun as one of the variables. So as you point out, they feel that solar flares are not going to be an issue, though if the launch window continues beyond tomorrow, they will, there is something happening on the sun that has them a little concerned in a few days, but not for tomorrow. Winds, it's a bit breezy right now, but nothing that in the forecast looks problematic. But then this cloud issue, Darius, and let me put this question to you the way a friend put it to me yesterday. You can fly on a commercial airline through storms. Why would cumulus clouds be a problem for Artemis II?
It's a great question, and I think it really comes down to the scale of this. So these clouds, these are cumulus clouds. These are friendly-looking clouds. They're the big, puffy, white ones. You maybe look for shapes in them. You don't usually think of them as being a threat. You understand why you might not want to fly through storm clouds, but these, they seem pretty harmless. But even clouds like this have a charge in them. And the taller they are, the more intense that charge is. And so the depth of that cloud cover, the thickness of it, really plays a role here in how NASA goes about their decision making. Because we've seen before what can happen when a rocket, a very large, this massive object that is spewing a trail of ionized charged particles itself, what can happen when it passes through clouds like these ones. And we saw that way back in Apollo 12. Take a listen to how the ground crew was reacting when Apollo 12 lifted off.
5, 4, 3, 2, 1, 0. All engines running. Commit. Liftoff.
Apollo 12 lifted off in the driving rain.
Pete Conrad reports the
36 seconds later, lightning struck the spacecraft.
I don't know what happened here. We had everything in the world drop out. I'm not sure if you get hit by lightning.
Again, it was not a stormy day. There was no indication that it was going to be lightning. But as that rocket passed through those clouds, it forced the charge to coalesce around the rocket. It struck, and things could have ended in disaster there if it wasn't for the quick thinking of a member of the ground crew. Fortunately, the astronauts made it. They made it to the moon. They made it back. Everything was fine. But it almost wasn't, Ian.
I love that historic reference as well, because I'll tell you one thing here at the Space Center, there are a lot of references to the Apollo generation, and the Artemis astronauts talk about how they know very much they stand on the shoulders of the astronauts and the huge NASA staff and crew that have come before them. Darius, Mahdavi in Vancouver, thank you very much.